So in this video, we are going to look at the e-commerce data pipeline project using GCP. Previously, we saw about Kubernetes. This time, we are looking at the GCP. So we'll go through the each files one by one. Here we have workflows. This CI/CD. For first, it installs Python and uses Ubuntu latest version and the lint and test. It's for checking if there is any syntax errors in Python or anything like that. In Docker, it's pushing the ingestion image into Docker. First, it's logging in and it's pushing it and pushing PySpark image and also the Airflow image. And most importantly, we have the flake test also here. Here we are mentioning which files not to test because these are some residue files like target.git. It's not required for the test. So next we have dbt test. And for your information, both are this CI/CD file is triggered on push in the main branch, and the dbt test is triggered on pull request and the push. In pull request, we have all the types: opened, synchronized, reopened, all the types. So here we have dbt test. It checks out the code first and installs dbt BigQuery, and it's authenticated with GCP, and it runs the dbt deps and the test. Deps will download all the external dependencies required for the dbt project, and the test will do all necessary tests that's mentioned in the dbt project. Next we'll go Airflow DAX. So these are some of the practice tags I did, and each one is different from one another. And this our tag, I guess. Yes, ingestion, transform, and load. This is what we saw in the other video also. And since it's GCP, we are not using Airflow here just for practice and deployment. In deployment, we have ingestion image Docker file, and in the KH we have this deployments, and it's repetitive. It's from the other project. In PySpark, we have PySpark image. In the docs, we have the architecture, like from the raw CSV, how it goes to the bucket, and how we are triggering the Dataproc using the Airflow Cloud Composer, and everything this one shows, and also the GitHub Actions. So we'll go to the DBT project. Here we have seats. Seats is for customer tier mapping in our case. So these are the mappings here. So what is seats? Seats is usually mostly it's constant values for specific values, constant values for specific keys. We can say like that. And these things never changes in our project. Even if it's changed, we can just it's very rare. So we keep it as seats in the CSV format. So the macros is like functions, like you give an input at and get an out. Here we have a clean stream.sql. So it will get the input from the DBT from the DBT algorithm, and takes in and trims the extra spaces and give uppercase on everything. So in the models we have two things: marks, staging. Let's go through marks first. So what is a mark? Mark is like it will get the data from the from the staged data and manipulate it and organize it according to the query we give here. So this ref is a stage. It's a stage reference of stage customer RFM. This stage we would have been giving in the staging files. Similarly, this is for country tier country mapping. So here we have did country tier mapping also, and in staging we have four files schema. Here it defines the each columns and schema related things for both tables like the stage product revenue and stage customer RFM, like minimum value, maximum value, and these things and these everything will go to the DBT test. Like when we initiate test, it will check for all these conditions if it's valid or not with the data. This is the source. It's like defining the sources for the stages. If you give, you are giving product revenue customer RFM, right? So in this file, in stage customer RFM, here in source e-commerce data customer RFM, we are giving here in source e-commerce data product revenue customer RFM. E-commerce data that product revenue will fetch the table from that schema. Similarly, for the stage product revenue also. So we have two test files. This will it's a it's a single test type. Like yeah, we give a query and get the value, like if it's true or not. So if this condition fails, the test will fail. Similarly here, if the product rank is more than 5, it will fail. Not fail, it will give an error in the test. So this is the standard YML file. And materialized table means it's not a view. It's like view versus standard table. So if you don't give materialized, it will be like a view. It will fetch the data every time from the source packages. We are using DBT tools and DBT expectations. So when we give DBT depths, it will get these packages from the registry. The profiles, since we are using GCP, this will BigQuery. We are giving BigQuery and method is OAuth. OAuth is like we don't need to give password in the terminal. We can just give Gcloud init and log in the GCP account and use the DBT directly. So that's it for the DBT project. This is the lineage graph from the DBT. Let's go to the GCP pipeline. In Cloud Composer, we are giving the tags. This is the Composer requirements.txt requirements file. Here we are giving the dependencies to be installed in the Cloud Composer environment. TL tag, you are giving all the necessary tags with the cluster configuration, the Dataproc cluster configuration, PySpark job configuration, and what to do on failure callback. We are giving it custom. We are setting default tasks, and we are defining all other tags. So these are the bucket paths. Here we have been, you would be giving bucket. Yeah. So we are giving bucket path, blob path, and everything. Cluster name, dataset ID, and we are defining the tags to run the composer. Submit job, delete cluster. We are also deleting after completing the job. And the thing to note here is trigger rule dot all done. What this means is even if one of the job fails, the cluster will still delete because we don't want to run the Cloud Composer cluster forever because Cloud Composer is very expensive and we can restart the cluster again if required, but we don't need it constantly. Yes, then we are loading into BigQuery. Here first we are ingesting, then creating cluster, ingesting into the bucket, then creating Dataproc cluster, then submit the PySpark job, and then delete the cluster and upload the data to the BigQuery. So here we have the three Python files to be run. Actually, these will be run in the DAG, I guess. Yes, actually, what I did here is that instead of giving each of these files as a reference, storing it in the bucket and giving as a reference, I took the short form of the summarized version of all these files and I have inserted everything here. So this reads CSV from GCS, right? If you go to ingest GSV, ingest into GCS, you'll see the exact code. So I've just composed it as a single Python file. So that's it for the GCP pipeline. Uh, I'll show it as a run. Also, we did a lot of Git things here. We have we have maintained version control and everything. Still, the Git repo has to be cleaned up a little bit. It's still somewhat messy, but we'll do it afterwards. For now, we'll see the GCP in the portal. You can see we have created a Cloud Composer environment and with the Composer requirements. So all the PyPy packages are installed. So now we have to copy this DAG into the bucket of the composer. Let's go to the DAG folder. So this is the path for the composer DAG. So the path is that. Okay, now we'll copy it. So storage cp. First go to the folder. So now that we have yes, so this is the bucket name. What we'll do is that cloud storage cp. We'll first copy the path of this proper bucket name. Bucket is e-commerce pipeline example. Actually, it's already there, but we'll still do it. Okay. So actually, mm, in this project, we use only the auto PySpark transform because that's the PySpark job. Ingestion is already it's already done and it's already stored in this bucket path. Yes, yes. As you can see here, this is the pipeline. First, we are already doing the ingestion here. We are mentioning raw path and the processed path, and we are reading the raw data from the GCS, GCP, and the bucket folder, and we are cleaning and writing the parquet within this code itself. So we are only using the not to PySpark transform file. It's already there, but we'll still try to copy it for the completion of it. The bucket path is ecommerce pipeline example scripts. The composes bucket. So this is the composes bucket. We can go from here, open text folder, gcloud cp sources, GCP, this way, right? GCP pipeline, cloud composer, that's GCP ETL dag.py. So the target is the bucket. We should add GS here in Google Storage and DAX. So I forgot to mention storage here. Yes, it has copied. Now we'll copy the this file onto PySpark transform because this is the only PySpark file we are using here because rest of the files are integrated within the DAX itself. Like we are having the ingestion task and we are defining we are defining the function and run it here itself. So there is no need to copy those other files. Also, this is a different bucket. This is the bucket I was using, e-commerce pipeline example. Here, scripts, scripts. Sorry, first it's source, GCP pipeline, output, for transform, py. Local copy is not supported. It's meant for cloud operations. Yeah, actually, I didn't mention the GS, so it thought like we are trying to move it locally. Yes, now this is completed. Now we'll go to the Airflow UI from the Cloud Composer. So we have to open the Airflow UI. Timeout. We're still signing in, and now we are inside the Airflow UI. So the Airflow UI will take the dash from the Cloud Composer bucket. This is the GCP tilde we have uploaded. And the run is successful. Since we have given schedule as daily, it has run automatically by itself. So you can see injection process done. Dataproc cluster is created. PySpark job is done, and the cluster is deleted, and BigQuery has been loaded. So the composer part is over now. You can just delete the composer environment now because it's very costly, and we don't have to run it unnecessarily. Now the GCP pipeline is done. Let's go to the e-commerce DBT. So here we had given all the stages, models, and the test. So actually we have according to the Git actions, it should do for every push, it should automatically check the DBTs and other Python files also. So now we will see the secrets of GCP credentials and the other things that we have given here in the GitHub portal. Here we have secrets and variables, actions. We have three things here: Docker password, Docker username, and GCP credentials. Docker username password is for that image ingestion for pushing the image to the Docker. GCP credential we can store here, and while doing the DBT test, it will be useful. So we'll go to the BigQuery next. I'll change the Wi-Fi connection since it's very slow now. So as you can see, we have a e-commerce data set. Customer are often and the product revenue as tables, and the customer tier mapping as that is seed, and this also another data set e-commerce DBT dev and the country performance and top products. These are all queries we have set before. Like this, the query I said before, it will automatically fetch the result when we run this. Yes, here we have this data sets. The snapshot is like is to track the changes in the data set. Yeah, it will do something like a version history. It will add another column, and it will have valid from valid to columns, and you will know which things has changed when without any data loss. Here it is. DBT valid from, DBT valid to, DBT updated at, and DBT SCD ID. This called like SCD. There is some SCD type 2. Slowly changing dimension type 2. It's a data dimensioning, data warehousing technique that tracks historical changes in a dimension data by creating new version records. So this is what the BigQuery is doing. So we already saw the queries, and yes, I think that's it for now. So this is what we did with the DBT. So yes, that's it for this project for now. You can refer the README for a more detailed review. And yeah, thank you.